This work is a joint collaboration with the Department of Forensic Science of Virginia and Cybergenetics. And we'll be talking about TrueAllele and its validation. So the basis of the data here is a cases where there are 72 criminal cases, 92 evidence items, from which 111 genotype comparisons are made. The criminal offenses are homicide, robbery, rape, weapons, and so on. The distribution of mixtures in the study were, as you see on the top, largely 3-person mixtures with a lot of 2-person and some 4-person mixtures. And the mixture weight composition, as you see on the bottom on a scale of 0 to 100%, was largely between 10% and 90% from the inferred matched contributors. So DNA mixture data is quantitative. There are tall peaks, short peaks, and their location indicates the allele, and the heights indicate the quantity of DNA. Here we see 2 taller peaks at 7 and 14, and 2 smaller peaks at alleles 10 and 12. Current threshold methods are really a data summary from a mathematical perspective, not so much of an interpretation as just summarizing what data is there, present or absent. And these all or none events are treated mathematically in these methods as if they have equal status. And so, for example, if you drew a threshold through these data about 100 RFU, you'd have 4 allele events, which would lead to 10 allele pairs, and therefore the probability which affects the match statistic is diffused across all 10 allele pairs, as opposed to being concentrated, say, on a more likely minor contributor allele pair of 10-12. So these cases were part of a larger set that were reviewed by the DFS laboratory in Virginia, and reports were prepared, I believe, and they got pretty good results for CPI. I mean, accounting from a genotype perspective, 25 genotypes weren't reported, but virtually all the items had a match score. And we see an average match statistic of around 1 million. Again, the x-axis is in band units, the log of the statistic. It's centered around 6, with good variation for CPI. That's pretty much between 1 and 10 zeros after the 1. And then SWGDAM 2010 occurred, and in a very good effort to help analysts account for the uncertainty in data, when you repeat experiments, you don't get the same peak heights and so on, those guidelines led to a higher threshold for human review in most laboratories, including in Virginia, and the stochastic threshold to account for these stochastic data ended up going up to over 300 RFU. And what you see is, while that's fine in this particular example, this locus, for calling the major contributor at allele 7 and 14, the minor contributor is not really there, and so much less use is made of that data, either with lower statistics or they're not there at all. Okay, and the result of that was a shrinkage of the statistics. Now, about half of the items became inconclusive, went up to 56 of the genotypes not being reported, and the average match statistic from the CPI, shown in green, of about 6, or about 1 million, came down to a much smaller region, shown in red, of average log LR of 2, which was an average match statistic of about 150. And so there was this loss of information on hundreds of cases, and the question is, what do you do? Do you just withdraw all these reports from the criminal justice system, or do you do something else? Well, Virginia elected to do something else. One of the provisions of the SWGDAM guidelines in paragraph 3.2.2 is that a validated probabilistic genotyping method can be used. TrueAllele Casework is a probabilistic genotyping method where on the left people interact with their data and ask questions, upload data and questions to a central server computer shown in the middle. The computer thinks about it for half a day or however long it takes to pull out all those genotypes. And when it's done, coming back over to the left, a person visually can then look at the genotypes, the data, match results, and so on. It had been validated, and in fact, here are 3 peer-reviewed papers. The first one is based on samples of known composition. The second 2, done in collaboration with the New York State Police, involve casework. And the system looks at many parameters: mixture weight, stutter, what the genotypes are, degraded DNA, and the uncertainty of every one of those parameters as well. And so, for example, for mixture weight, you can visually see it as well in the system or on the screen as separating the data into, in this case, 2 contributor components, a minor component of 25% and a major component of 75%. So the system works at the level of genotypes corresponding to each contributor. There's uncertainty in all science and in parameters, so that's expressed in probability. But it works with genotypes, not with lists of alleles. And so in trying to infer genotypes, what the computer does, like other systems that have been built for this by others, is it does a very thorough consideration of every possible genotype solution for all the data that it sees. There can be multiple items of evidence or swabs. And it tries out almost anything that would be an explanation, even for peaks that aren't there. It's objective in that no use is ever made of a comparison genotype. It writes its answers down and proceeds from there in making comparisons. It tries to explain the peak pattern in the sense that it's trying out all sorts of patterns, different heights, locations, bars all over the place. But better explanations have better likelihood with an end result that at this particular locus, and this is from one of the cases, the probability of the minor contributor being a 10-12 when a comparison is made, the probability is concentrated here at 98%, which leads to virtual single source preservation of the identification information. So now we end up with a measure of the sensitivity of the system. In blue, this is what the TrueAllele system did. On the left, you see in terms of not reporting, it didn't report on 9 out of reported but not a positive match statistic on 9 out of the 111 genotypes. There's a much wider range, again, as we saw before, of identification information spanning from 0 to 10 to the 22nd, which reflects the concept that real identification information from samples goes from no information to full single source information. The average is about 11. I guess I could say I'll spinal tap the system goes up to 11, but I won't. And so that's about 100 billion as an average. And it's also worth noting, I won't be showing any joint statistics here, that the CPI statistic was higher than TrueAllele for 15 items of evidence. TrueAllele doesn't just add zeros. It tries to calculate the information that's present. And in fact, I'm thinking about 5 of the CPI scores that ended up not being reported, the computer found no support for those matches. Okay. The system is also specific in that it's one thing to say, well, here's an inclusion, what's the match statistic with the inclusion, but there's also a question of exclusions. And so for this experiment, for each inferred genotype, we took the probabilistic genotype and in the interface compared it against all the references from the other 71 cases and generated over 10,000 match comparisons on this data set. And then we looked at what was the log or the likelihood ratio, what was the information content. 0 is all the way at the right border, and even though it's possible rarely, but it's possible to go beyond 0. In this particular study, the exclusion information was centered all in a negative distribution, centered around 10 to the negative 20th. And so the conclusion is we didn't find any false inclusions in this study. TrueAllele is a statistical program in the sense that once you go beyond 2 or 3 parameters, and in TrueAllele there are hundreds of different variables expressing uncertainties, genotypes, degraded DNA, stutter, all that sort of, all those factors that affect what the data look like. And that's how these methods work, is you try out all the different ways of creating the data from these parameters. When you explain data like this, now that you have hundreds of variables, you can't solve it with a simple analytic equation or brute force search, because it would take centuries more than what we have in time to produce a useful result for criminal justice. So instead what is done is computer simulations that, like in the rest of think of it like a population survey for sampling a few hundred alleles. You sample from the true distribution. We typically sample about 100,000 times. And so you'll get some variation every time you repeat the experiment, just like in PCR. The peak heights are different. The exact distributions of the genotypes and other parameters will vary. By how much? And so on the x-axis, you see the results of the first so each point on that scatter plot is showing the results of 2 independent computer runs on that evidence data, one on the x-axis, one on the y-axis. And for example, at 1212, we see points that are clustered, and what you're seeing is that the numbers are 1212, not 1219. They're lining up along 45 degrees, and visually it looks reproducible, but also we can calculate a within-group standard deviation that shows less than half a log unit standard deviation as variation between replicate experiments. The outcomes in Virginia for the 144 cases analyzed was that we generated 72 case reports. There were 9 trials in federal, military, and state jurisdictions around the state. I testified in 7, and our co-author Lisa Shermer-Wood, a Virginia scientist, testified in 2 of the trials. And the charges were homicide, rape, and so on, and the sentences are shown in the last column. So the conclusions of the study is that TrueAllele casework DNA mixture interpretation is a reliable method. It's sensitive. It finds the right inclusions based on the comparisons that we did, and provides a quantitative likelihood measure of that as a positive number. It's also specific. It doesn't falsely find incorrect inclusions. In fact, it quantifies the exclusions, which can also be good for exculpatory purposes. And the method is reproducible. If you run the computer multiple times, you will get essentially the same answer. And so, in conclusion, TrueAllele computer genotyping is more effective than human review of the same DNA mixtures, and there's more information about this available on our website. Thank you.